So in this video, I'm going to discuss about this problem on Leetcode, problem number 496, next greater element 1. So this problem is a slight variation of a pretty standard problem, of finding the next greater element in an array. So the standard problem is something like we have to find the next greater element for each of the elements present in the array. So first I'll discuss about that problem and then I'll come back to this one. So the problem next greater element on the right side or left side of an array is a pretty standard problem. So let's say we have an array, something like this. So let's say we have an array with these elements. So what we have to find is the next greater element for each of the elements present in this array on the right side. So let's say for 1, the next greater element on the right side is 3. For 3, the next greater element on the right side is 6. For 6, the next greater element on the right side is 9. For 2 also, the next greater element on the right side is 9. For 9, we don't have any element on the right side, so we can simply output -1. So how do we approach this problem? So one brute force solution which comes to my mind is like simply iterating each of the elements with one loop and then have another loop for iterating all the elements on the right side of that element. And as soon as we encounter any element which is greater than that particular element, then we can simply print that element. So the time complexity of that brute force solution will be order of n square, since we are using two loops, one inside the other. So another optimized way of solving this is using a stack. So how do we solve this using a stack? So using a stack, what we can do is we can one by one push each of the elements inside the stack, and before pushing any element inside the stack, we will check that if the element at the top of the stack is smaller than the current element, then the current element will become the next greater element for that particular element, and we can keep on popping the elements as long as the current element is greater than the elements at the top of the stack. So I'll demonstrate this. So this is the stack. So first we will, since the stack is empty, we will simply push 1 inside the stack. Now we have 3. So is 3 greater than 1? Yes. So the next greater element for 1 will become 3, and we can pop this 1 out. And then since we don't have any other elements, we can push 3 inside the stack. Now we have 6. So is 6 greater than 3? Yes. So 6 will become the next greater element for the element at the top of the stack. So the next greater element for 3 will be 6, and we'll pop 3 out. Now we don't have any other element, we will push 6 inside the stack. Now we have 2. So is 2 greater than 6? No. So we'll push 2 as well. Now we have 9. So is 9 greater than 2? Yes. So the next greater element for 2 will be 9, and we can pop 2 out of the stack. Now we have 6. So is 9 greater than 6? Yes. So the next greater element for 6 will be 9, and we can pop 6 out of the stack. And now we can push 9 inside the stack. So now, since we have iterated once through all the elements, and we have found out the next greater elements on the right side for some of the elements, for the remaining elements which are present inside the stack, we don't have any next greater element, so we can one by one pop those elements out of the stack, and the next greater element for each of these elements will be -1. So we have 9, pop 9 out, and the next greater element for 9 will be -1. So this is the optimized way of solving this particular problem. Now coming to the time complexity of the solution. So uh, since we are so let's consider how many operations we are making. So for each of the element in the array, we are either once pushing it inside the stack. So for n elements, that will be n operations, and we are also popping out some of the elements out of the stack, and the maximum number of operations could be again n. So we can either uh, n. So for each element, we can at max make 2n operations, one for pushing it inside the stack and one for popping it out. So the time complexity of this approach will be order of 2n, which is equal to order of n. So this is a pretty optimized solution. So now let's apply this uh, to this particular Leetcode problem. So this problem, so what we have to do in this particular problem is we have two arrays, nums1 and nums2. So what we have to do is for each of the elements present in nums1, we have to find the next greater element of this element in the nums2. So let's say we have 4 in nums1. So we will find out where 4 is present in nums2. So we find that 4 is present here in this nums2 array. So the next greater element in this nums2 for 4 is -1, since we don't have any element greater than 4. Similarly for 1 is present here in nums2, and the next greater element for 1 in nums2 is 3. So we will output 3. Similarly for 2, we see that 2 is present here in nums2, and since we don't have any element on the right side of 2, the next greater element will be -1. Now coming to example 2, so we have 2. So first we find out 2 in nums2. The next greater element for 2 in nums2 is 3. So we output 3. Then we have 4. So in nums2 we have 4 present at the last index. And since we don't have any element on the right side of 4, so we will output -1. So how can we solve this problem? Let's discuss that now. So we have two arrays, nums1, 4, 1, 2, nums2, 1, 3, 4, 2. One more important thing to note in this particular problem is that all the elements are distinct. So it's written here that you are given two distinct zero indexed integer arrays. So no element can repeat in any array. So how can we solve this is first we'll find out the next later element array for nums2 array. So it will be for 1 the next greater element is 3, for 3 4 is the next greater element, for 4 we don't have any next greater element. Similarly for 2 also we don't have any next greater element. So instead of constructing an array like this, we could have a map since the elements are distinct. So map can be something like, let's say, next greater element map. We construct a next greater element map. So for 1, the corresponding next greater element is 3. For 3, next greater element is 4. For 4, -1, and 2, -1. So we have this map so that we can uh, access these values in order of one time. So now we can start iterating the elements in nums1. So we get 4. So we can check this map and find out that what's the next data element for 4. So let's say the final answer array is this one. So for 4 the next data element is -1, so we'll push -1. Then for 1 the next data element in this map is 3, so we'll push 3. Similarly for 2 the next data element is -1, so we'll push -1 inside. So in this way we can solve this problem. Now let's code this up. So I'll be coding in C++ and I'll be using the STL library of C++ to construct stacks and map. So we'll first construct the map for getting the next data element, and to find the next data element we'll need a stack. Then we can start constructing the next data element map for elements in nums2. We can one by one iterate the elements in nums2 and can check that if either the stack is empty. If the stack is empty, if the stack is not empty, sorry, and the element at the top of the stack is less than the current element, then the next data element for the element at the top will be the current element, and then we can pop that element out of the stack, and then we can push the current element inside the stack. And for the remaining elements which are present in the stack, we don't have any next data element, so we can simply put -1 as the next data element for these elements. Now we can construct the final answer array. We'll iterate all the elements in nums1 and push the next data element in nums2 and return this answer array. So now let's run this for these sample test cases which we have. This one is passed. Now let's try this test case. This one is also passed. Now let's run it for all the test cases. So this is how we could approach this problem using the next data element problem. So there are many other problems which indirectly use this particular concept, finding the next data element. So another problem is to find the next data element on the left side of an array. So let's say we have an array like so the next data element on the left side of 2 is -1 since we don't have any element. For 1 the next data element on the left side is 2. For 6 we don't have any element greater than 6 on left side. For 8 also, and for 3 the next greater element will on the left side will be 8. So how could we solve this? So it's pretty straightforward. So it's very much similar to the next greater element on the right side, just that we can start iterating elements from right. So we'll push 3, then we have 8. Is 8 greater than 3? Yes. So next greater element for 3 will be 8, and then we'll push 8. Then we have 6. Is 6 greater than 8? No. We'll push 6. 1. 1 is 1 greater than 6? No. So we'll push 1. Then we have 2. Is 2 greater than 1? Yes. So 2 will become the next greater element for 1. We'll pop 1 out. Is 2 greater than 6? No. So we'll push 2. The remaining elements, we don't have the elements which are remaining in this stack, we don't have any next greater element for them. So we'll pop them out one by one. For 2, -1, 6, -1, 8, -1. So in this way, we can solve this particular problem as well. Another problem is to find out the maximum area under a histogram. So that also we can solve using this approach only. So we could find out the next smaller element on the right side and next smaller element on the left side. So maybe I'll discuss that in some other video. Also, I'll put the link to the solution in the description.